Welcome to qnawire.
For part A, we're asked to estimate the average deceleration of the atomic beam. So the momentum of the atom, PA, is going to be equal to the mass of the atom, MA, times the velocity of the atom. So we're told the mass of the atom is 10 to the minus 25 kilograms. The velocity is 1 kilometers per second. So we want to convert that to meters. So that's 10 to the third meters per second. And the momentum of the incoming photon is going to be equal to Planck's constant divided by lambda, where lambda is 500 nanometers, or 500 times 10 to the minus 9 meters. So the final momentum of the atom, P sub F, minus the momentum of the atom, P sub A, is equal to negative the momentum of the photon, gamma. That's because the final momentum there, minus the initial momentum of the atom, is going to give us the deceleration value, right? Because what this is doing is giving us the force that's acting on the atom. So we also know that the time t is equal to 10 to the minus seconds and the force is equal to negative momentum over time. Momentum of photon, P gamma, over the time, T. So plugging these values in, find that this force is equal to 1.352 times 10 to the minus 90 newtons. Speaking of newtons, we can use that to find the acceleration, as according to law, force is equal to mass times acceleration. So this is equal to m, the mass of the atom, m sub a, times the acceleration of the atom, a. Looking for the acceleration, a, we find that it's equal to the force divided by the mass of the atom, m sub a. Plugging in these values, we find that this is equal to negative 1.352 times 10 to the 6 meters per second. Squares per second squared. We're dealing with acceleration. And the negative sign is because it's deaccelerating. Now, for part B, we're asked to find the order of magnitude of the distance over which the atoms in the beam are brought to a halt. So let's scroll down a little bit so we have enough room here. Call this part B. So the distance at which the atoms come to a halt can be found using the final velocity of the atom, v sub f, minus the velocity, v sub a squared, is equal to 2 times the acceleration that we just found, distance s. Well, the final is 0 because it comes to a halt. So we find that s is equal to negative v sub a squared. That's okay if that negative sign exists. Our a value is negative divided by 2. So this distance out to equal 0.3 meters. We can box that in as our solution, part B.